Introduction to Prestress Concrete Design. Intended learning outcome. Ito yung mga dapat nating matutunan pagkatapos ng lesson na to. After studying this lesson, the student must be able to calculate stress in bending, shear, and torsion. So, papag-aralan natin yung stresses in bending, shear, at torsion. First, shear stress. Force tending to cause deformation of a material by slippage along a plane or planes parallel to the imposed stress. The resultant shear is of great importance in nature, being intimately related to the downslope movement of earth materials and to earthquakes. This is the formula for shear stress. Tau V is equal to VQ over IB. V is the shearing force, Q is the statical moment, I is the second moment of area about the centroid, and B is the breadth of section at a given point. Next is bending stress. The normal stress that an object encounters when it is subjected to a large load at a particular point that causes the object to bend and become fatigued. Bending stress occurs when operating industrial equipment and in concrete structures when they are subjected to a tensile load. Ito naman yung bending stress formula. FB is equal to MC over I, where FB is the bending stress, and M is the moment at given point, I is the moment of inertia, and C is the distance of the outmost fiber from the centroid. Lastly is the stress due to torque. Shear formed by torsion exerted on the beam. Torsion occurs when two forces of similar value are applied on opposite directions, causing torque. And this is the formula for torsional stress. Tau T is equal to T times R over J, where tau T is the torsional stress, and T is the torque applied, R is the radius, and J is the polar moment of inertia. Para mas maintindihan natin, magbigay tayo ng mga examples.
Hi, so yung napili ko para sa video presentation na to is yung Module 2, which is different stresses. Example number 1, meron daw tayong girder na 320 mm at 180 mm. Yung overall depth is 780 mm. And then yung thickness ng web is 180. So meron daw tayong horizontal stress at a point 420 from the soffit. So yung horizontal stress doon is 28 Newton per millimeter squared. Next is may shear stress due to transverse load acting at the same point na 4.80 Newton per millimeter squared. So sabi dito, determine the increase in the principal tensile stress at this point if the T-section is subjected to a torque of 19 kN meter. Para makuha mo yung B2, yung overall depth, minusan mo lang ng 180 para makuha mo yung sukat ng B2. So, 600 mm. So, una natin gagawin is kunin muna natin yung principal tensile stress without yung torque. So, ito yung gagamitin na formula. Kung isa-substitute natin yan, magiging shear stress natin, which is 4.80 squared. Negative 0.80 Newton per millimeter squared. So, sunod na kunin mo naman is yung shear stress due to torque doon sa center ng web. So, ito yung magiging formula natin. Shear stress due to torque is equals to 3 times yung torque na binigay times Ti all over summation ng Bi times Ti raised to 3. 19 times 10 raised to 6 itong torque kasi naka siya kilonewton meter. So, bago mo i-times yung Ti, which is 180 over 320 times Ti na 180 cube times yung B2 600. Shear stress due to torque 1.91 Newton per millimeter squared. Pangatlo naman is, kunin natin yung total shear stress. Ipa-plus lang natin yung nakuha nating shear stress doon sa binigay sa problem. 4.80 magiging 6.71 Newton per millimeter squared. So, pang-apat na gagawin is, kunin naman yung principal tensile stress with torque. Shear stress natin dito is 6.71. Negative 1.52 Newton per millimeter squared. So, with torque minus without torque para makuha mo yung sagot. So ito na yung sagot. So, for example 2 naman, meron daw concrete beam na may rectangular section, 180 mm wide and 330 mm deep. Prestressed by a parabolic cable having an eccentricity of 100 mm at the center of span, reducing to 0 at the supports. So, yung span ng beam is 12 meters and meron siyang sinusupport na live load na 2.10 kN per meter. So, sabi, determine the effective force in the cable to balance the dead and live loads on the beam. So, yung unit weight ng concrete kakailanganin din natin, which is equivalent to 24 kN per cubic meter. So, una mong gagawin, kunin muna yung self-weight. So, para makuha yun, times mo lang yung base niya na 6 times yung height. Naka-meters dapat siya. Times yung unit weight ng concrete. Yung self-weight ng beam is magiging 1.43 kN per meter. Kukunin mo naman is total load or yung Q. Ipagpa-plus mo lang yung nakuha mong self-weight plus yung sinabi dito na live load 2.10. So yung total load is 3.56 kN per meter. Pangatlo mong gagawin para makuha mo yung effective force, isa-substitute mo lang sa formula na to yung itong Q na nakuha mo times mo yung length all over 2. So, yan yung sagot. 21.36 kN. Example number 3. Meron daw pre-stress concrete beam na may span na 12 meters of rectangular section 145 mm wide and 325 mm deep is actually pre-stressed by a cable carrying an effective force of 194 kN. The beam supports a total uniformly distributed load of 8 kN per meter, which includes the self-weight of the member. Compare the magnitude of the principal tension developed in the beam with and without axial pre-stress. So, first step, kunin muna natin yung area, base times height. 47,125 mm squared. Kunin naman yung moment of inertia, 1 over 12 times base times height raised to 3. So, magiging 41.5 times 10 raised to 7. Third step, kunin mo naman yung shear force at the support. So, ito yung formula. Yung uniformly distributed load mo, times mo lang sa span niya, all over 2. 8 times span mo na 12. All over 2. 48 kN. Pang-apat na step, yung kunin mo naman yung maximum shear stress at the support. So, ito yung formula 3 times yung nakuha mong shear force sa support all over 2 times base times height. Itong 48 na shear force natin, nakakilonewton siya. So, ita-times natin siya sa 1,000 para maging yung unit nung magiging sagot is Newton per millimeter squared. Maximum shear stress is equals to 1.53 Newton per millimeter squared. Yung limang step naman is yung principal stresses. Square root mo to, magiging makakancel na yan. Wala na rin. So, ito magiging 2. So, 2 divided by 2 is equals to 1. Kaya, ang matitira na lang is ito. Yung shear stress natin na to, compression and tension. So, yung pang-anim na step, axial pre-stress. Ito yung formula niya. Yung effective force, i-divide mo lang siya sa area. Yung effective force mo is, ito, 194 kilonewton. 4.12 Newton per millimeter squared. Pang-pitong step naman is kukunin natin yung maximum and minimum principal stress. At ito yung formula nun. Shear stress mo, ito, 1.53. So, simplify mo lang. 4.12 divided by 2 is 2.06 plus and minus. Pag sinimplify mo to, ang makukuha mo is 2.80. Dito meron kang positive 4.86 Newton per millimeter squared compression. Sa minimum, meron kang negative 0.74 Newton per millimeter squared tension. Magiging sagot is yung maximum shear stress na nakuha mo, which is ito, less yung F minimum all over ulit nung maximum shear stress. Times mo lang sa 100 para makuha mo yung percentage. So, ang magiging sagot dyan is yung principal tension is reduced by 52%.
We would like to introduce ourselves. I am Abella-Elefane.
Hi, I am Mia Batong Bakal.